Hello everyone. Today I'll be going through the question 16 to question 20 of the SMO Junior 2018 paper. First, let's take a look at question 16. We are given a minus b equals to 3 plus square root 8 and b minus c equals to 3 minus square root 8. And we have to find the value of the following. So since we have the first two equations, we can get the third one by adding these two equations to get a minus c equals to 6. And see, we realize that a squared plus b squared plus c squared minus ab minus bc minus ac equals to half of a minus b squared plus a minus c squared plus b minus c squared. We sub in these values as obtained from the first three equations to get 35. Moving on to question 17. A teacher organized an outing for her students. The outing cost $T, regardless of how many students participated. This cost will be shared equally among the participants. If all her students were to participate, each student will pay a whole number of dollars. After the teacher announced how much each student would pay, there were 4 students who decided to withdraw. Without these 4 students, each of the remaining students would still pay a whole number of dollars. However, on the day of the outing, another 2 students were sick and absent. As these 2 sick students did not participate, each student who participated in the outing had to fork out an additional $3. If the teacher has between 24 and 40 students inclusive, find T, which is the total cost of the outing. So first, we let the total number of students in the class be n, which means that n minus 6 students went for the outing. With this information, we can form this equation. The left-hand side shows the amount of money the students who went for the outing had to pay extra due to the 2 sick students, and while the right side of the equation shows the amount that the 2 sick students did not pay. Making t the subject of the equation, we get a quadratic. From this equation, we see that 3n squared must be even since everything else in the equation is even. Therefore, we let n equals to 2k, where k is a real integer. Subbing this equation into our original one, we get this, t equals to 6k squared minus 30k plus 36. Note that t over n must be a whole number, and that n is a factor of t. That means n must be 36, given from the right-hand side of the equation. And thus, t equals to 36 times 3 times 18 minus 15 plus 36, which is 1440. Moving on to question 18. In the following diagram, triangle AOB is an isosceles right-angled triangle if OA equals to OB equals to 40. Point D lies on the side OB such that OD to DB equals to 3:1. Point E is a point on AD such that OE is perpendicular to AD and OE extended meets AB at C. The question wants us to find the value of 7 times of the area of triangle OAC. So first we find the length of OD, sorry there's a typo, which is equals to 30 since we have the ratio of OD to DB is 3:1. And by Pythagoras theorem, AD equals to 50. We can see that triangle DOE is similar to triangle DAO since angle DOE equals to angle DAO. And from this, we can find the length DE, which is equals to 18, since the ratio of the sides is the same. And from this, we get A equals to 32. Next, we form a square OAFB, shown from this figure. We extend OC to meet BF at G. This gives us angle GOB equals to angle DOE equals to angle DAO. And by the ASA property, triangle GOB and triangle DAO are congruent. Thus, BG equals to 30 and OG equals to 50. We observe that triangle BGC and triangle AOC are similar. BG over AO equals to 30 over 40, and OC equals to 200 over 7. And thus, the 7 times of OAC equals to 3,200. Next, we look at question 19. We have to find the value of this. So first, we look at one root, the first root. So square root 9 squared plus 19. We take x to be 10, and substituting x equals to 10 into that square root gives us x as shown here. Thus, square root 9 squared plus 19 equals to 10. And we do the same thing to each of these square roots in this equation, and it will give us a nice sum, which is 10 plus 20 plus 30 all the way to 640 equals to 20,800. And now for the last question, 20. If x is a positive real number that satisfies x squared equals to square root 3, evaluate this. For this question, it is important to use the algebraic formula a squared minus b squared equals to a minus b, a plus b. So for the first fraction, you multiply x plus 1 to both the numerator and the denominator. The objective of this is to get a common denominator of x squared minus 1. So as you can see here, we have x plus 1 over x squared minus 1 minus x minus 1 over x squared minus 1, keeping the last fraction the same, which is minus 2 over x squared plus 1. We get 2 over x squared minus 1 minus 2 over x squared plus 1. And now we do the same thing. We get the denominator to be x to the power of 4 minus 1, which is using the same property. This gives us the denominator to be 2x squared plus 1 minus 2x squared minus 1, which gives us 2.